Mr. Tiwari, you please unmute yourself. He has joined, but he is muted.
Sir, within a half minute, I'm joining.
Oh, sure. Please take your own time. Nothing like that.
Okay. Thank you, sir.
Want to leave?
Yes.
Okay.
Sir, I'll seek your blessings.
Thank you. My blessings are always there.
I'll take a photograph with you. You send it with your phone is better.
Just 1 minute.
Thank you.
नहीं करना तो कहाँ फोटो नहीं आ रहा है ना कैसे सर नमस्कार
नमस्कार
फारूक साहब कैसे हैं
ठीक है आपके क्या
बस ठीक ठाक हूँ
सर प्रणाम सर नमस्कार सर मनोज तिवारी
नमस्ते
यस सर
sorry actually 2 of my students they dropped in so I had
अरे
to
अरे
spend
सर
some time with them.
आई अंडरस्टैंड सर नो प्रॉब्लम
Oh, एक था भासी
हाँ आई नो भासी सर फ्रॉम द केरला यस
from Kerala and other one is actually TK Naik, Gopal Naik.
Gopal Naik was earlier in I think Triple IT Hyderabad sir no sir yes
Triple IT Bhubaneswar director he was.
अच्छा yes
So now I think we can start.
yes sir yes no problem
Now ये मैंने कही अछंती की रेणु एंड तापर बीए हमर बीसी ओके Good evening everybody. A very hearty welcome to 31st Distinguished Lecture Series being organized by INAE Bhubaneswar chapter and IIT Bhubaneswar, IMMT Bhubaneswar and IEEE Bhubaneswar chapter. So one thing that actually I would like to mention here, that this year we had the privilege of organizing INAE annual convention here in Bhubaneswar, in this university, SOA University, who is the host, and also they are the host for our distinguished lecture series. This was a very resounding success and one of the best INE convention, according to organizers, the INE central team, that has happened in recent time. It was all because of the support and good wishes of friends like you that such a thing could happen. So today on this 31st distinguished lecture series, we have Professor Manoj Kumar Tiwari, my former colleagues. He has been the founding director of IIM Mumbai since August 23. Because of his effort, National Institute of Industrial Engineering Training in Industrial Engineering, NITI, Bombay, got converted to an IIM, and that is, I believe, 23rd IIM in the country. And all it is due to his effort. I know actually how he has really struggled to make it. So he was a professor with higher academic grade pay in the Department of Industrial and System Engineering at the Indian Institute of Technology, Kharagpur. He is retired. He is actively involved in research relevant to the application of optimization, modeling, decision support system, and data mining in logistics, supply chain management, and manufacturing research domains. He is associate editor and senior editor of several renowned journals like IJPR, POMS, JIM, IEEE, SMCA, INS, and CAIE. Professor Tiwari had led numerous projects and consultancy assignments with prominent industries and government organizations, including Indian Air Force, Procter & Gamble, Tata Hitachi, and ports located in Eastern India. In addition, he aggressively engaged in collaborative research with partners from Loughborough University of UK, Institute for Manufacturing at the University of Cambridge, UK, Warwick Manufacturing Group, UK, Durham University, UK, and the University of Connecticut, USA. Professor Tiwari is an author of more than 354 articles in leading international journals, which H index of 82. He is a fellow of the National Academy of Sciences, India, Indian Academy of Sciences, and the Indian National Academy of Engineering, the Institution of Industrial and System Engineering, USA, and also recognized with David F. Baker Distinguished Research Award of IISc, USA. So, and I had the actually opportunity of working with him for a number of years, and I know him very intimately, and how passionate he is actually with his students and with his research work and other things. So under his leadership, I'm 100% sure that IIM Mumbai will go to a much greater height. Incidentally, this has been identified as the lead institute for supply chain and logistics management in the country by Government of India, and it is all under his leadership. Today, the topic actually which Professor Tiwari has selected, that is key issues and solution through large language models in supply chain management. That is this competent area. The The challenges within the supply chain ecosystem are highly complex, characterized by interdependencies and web of factors influencing each other. Successfully overcoming these challenges results in smart and combined modeling method that can resolve the complexities. Recent breakthroughs in artificial intelligence through the utilization of advanced techniques such as large language models, knowledge graphs, and transformers have provided innovative solutions for addressing such complex issues. These have been remarkable. There has been remarkable emergence of generative AI techniques, particularly large language models and innovative tools for taking these difficulties into in this presentation. Our primary objective is to demonstrate this efficacy of employing such generative AI techniques in addressing supply chain problems. The presentation is dedicated to describe the practical implementation of state-of-the-art technology, illustrating the capability of revolutionizing the landscape of logistics and supply chain management. This is actually the abstract of the talk. And one more thing which I would like to mention here, it is due to Professor Tiwari's effort. You see, I am Mumbai and I am Sambalpur. They have joined hand in creating another institute here in Anugul, particularly to address the supply chain management issues of coal in this part of the country. And I think this is a very, very laudable things which is happening, and all this credit actually goes to him. So with this brief remark, may I now request Professor Tiwari to make his presentation.
Thank you, sir, very much, sir. Professor Acharya, my slide is visible, sir.
Yes, it is visible. Absolutely.
Thank you, sir. And yeah, sir, let me express my profound regards to Professor Acharya, Professor Farooq Mistry, Professor Misra ji, Professor Kalmadkar, and my other friends and seniors who are here. And I just want to reveal that my NITI joining is basically a gift of Professor Acharya. So he was, I always treat him just like, fatherly figure to me. And whenever I was in trouble in my career guidance, he has been a constant source of inspiration for me, because my rise and his rise is very much similar, like starting from a village to reaching to the faculty positions in IIT Kharagpur. So actually, I treat him as my role model for many things. And Professor Acharya was one who guided me to go and join here. And I saw he in action when he was director of IIT Kharagpur, and how much effort he made to bring a lot of money from the government and established the infrastructure, particularly Nalanda and all other hostels, several hostels, schools, central school, road, campus network, everything became very, even the around 50-year-old problem of overbridge, that also he brought for IIT Kharagpur. So, sir, basically you are my role model, and I am doing nothing except to following your footsteps and then taking one by one challenges, and which is due to grace of God coming true. And also government is very supportive, sir, to support me in this regard. And now coming to this topic, sir, I tell you just there are a lot of work is going on in the domain of logistics and supply chain management. And recently we observed that because of advent of the AI and many other decision-making tools, they are basically some way or another way being engulfed by the ongoing researches in the domain of advances are called generative AIs. So worldwide efforts are being made actually that how the complex problems of supply chain, which are interwoven between the different entities, like right from the supplier, warehouses, manufacturers, distributors, retailers. So this huge network is there for any supply chain. And then question is that how to actually address them through this new route. And we were working with the MIT professor, Professor David Simchi Levy, on this issue. And he has been constantly guiding us that, okay, how the newer models like transformer, LLMs can be used to address the simulation, optimization, as well as some of the prediction kind of problems through the AI. So, so you can say, sir, that these are the different people who are always putting us to take up these challenges and then helping our institute and students actually to learn newer things and then come and stand before the many of the firms to defend that what are the newer things are happening and in what way practically it is going to be useful for them. Like say, there is one cement company, sir. They approached us for solving some of the problems of their large network of dealers as well as district level, as well as, that is tahsil level. So we applied almost all the tools of AI to predict their monthly, quarterly demands and then accordingly design their network. And I must say, error was less, and they are getting the benefit out of all such predictive tools. Similar things we observed for a steel company where they were purchasing around 104 type of steels, and then we did this kind of AI-driven modeling for them, and now they are saving a lot of money because of advanced planning of their inventory and purchase orders actually. So keeping that particular base in mind, sir, we just want to move ahead and describe you the overall scenario of the country. Sir, as you can see that in the logistics domain earlier, our cost of transporting the goods from one place to another place was pretty high, around 14% of the GDP. But if you see from 2014 onwards, the massive effort which government has put on creating infrastructure through different schemes like Bharat Mala, Sagar Mala, Parbat Mala, and many of the PM Gati Shakti kind of plans that they have devised in 2021, and some of the corridor kind of concept which has been brought by the government. So, and also the massive focus on the creation of the multimodal parks and warehouses, and all these things has linked to, and also the number of airports has gone at least 3 times more than what it was before the 2014. Similarly, many other ports has come up to handle large volume of containers as well as bulk items. So this has resulted in the massive movement of goods and services to the India and from India to outside. And because of the ease of doing business and bringing digitization kind of element in payment and other things. So one paper is...
Slides are moving.
Yes, I'm coming to that. Slide is not moving, sir. This is now you've got next slide. Hello?
Yes, I am able to see the next slide.
So this is the slide I was there, sir. So I just wanted to explain it. So you can see supply chain logistics scenario in India, sir.
Yes. Go ahead.
So what I'm trying to say, sir, recently one of the report given by the Ministry of Commerce and Industry under the DPIIT, they are claiming that it has almost reaching near to 9%, which was the target earlier also. But meantime, sir, under the PM Gati Shakti National Master Plan, a plan was designed by the government through BISAC. This is an Bhaskaracharya Institute of Geospatial Technology situated in the Ahmedabad. So what they were doing, sir, they were planning all the routes and development of the logistic services, parks, details, keeping in mind the requirement of many other ministries also into their picture. And this all been digitized with the help of longitude and latitude kind of details available in the GIS, GPS. And based on that, actually, sir, a comprehensive what you call geospatial technology based route has been prepared. An idea was that all the infrastructure related details should be prioritized through this what you call different kind of mapping along with the combining and accelerating the resources, and they have to comprehensively evaluate and look into account the details of like power supply, water supply, fiber cables, etc., which are falling in that line, so that any road network is being created. All the supporting facilities should also be planned at that time itself. So this has resulted in many of the interdepartmental coordination to be reduced like anything, and because of that, project planning cost has come down considerably, and time has also been reduced. So what we thought and what we discussed with the Ministry of Higher Education, that since because of this scheme, a lot of newer logistic challenges are coming up. Like say when you are using RFID, when you are using digitization, when you are using all the some optimization, simulation and machine learning tools, or when you are using control tower to track the containers from one place to another place, or we are going to map the multimodal logistic park where facilitation among the change of the items from rail to road to the again to the ship or from any other which interchangeable mode actually. So whenever it happens, then how to facilitate the process and how dashboards as well as the many of the digital display boards, they should be there actually to help the people to understand that okay, what next stage to be done. So that sort of skill set is needed, and accordingly in the all the domains like shipping management, port management, digital supply chain, as well as how effectively the food supply chain, which has massive network needed to be actually understood properly by the students. So around such 14 subjects we have designed and requested the all the higher learning institutions to incorporate and see the syllabus and also try to include them for the teaching purposes. So keeping that in mind, sir, we now notice that some of the major challenges which the supply chain is facing are like how to find out the uh, uncertainty in the demand, which is a perennial challenge before any company. And then many of the disruptions which are coming up because of the sometimes like say agitation by farmers or some sort of diseases or some sort of like railroad network disturbances or because of some natural calamity or because of some international conflict, like say one of the firms which we consulted recently is the pharmaceutical giant. And sir, they have majority of the plants which are producing vaccines, they are situated in the Europe. And because of the Ukraine-Russia conflict, they are not able to send their vaccines through the air. And if it is sent by air also, then they are going into the deep China and then coming back and sending to the many Asian countries. So they have given us assignment to find out कि ship route is taking around 18 days if they want to send from one port in the Europe to the India or Sri Lanka. Then the question is that कि how many days stock they should maintain at temperature of say 2 degree or 3 degree centigrade at their port as well as the port at India. So that the vaccine should be present. Not only vaccine of COVID, there are many other vaccines also which are be required for immunizing the children and other small kids. So all those things actually they need to be transported in a quick amount of time. But when you want to delay it, then they have to maintain at certain temperature and their stock need to be maintained at different ports. So when we analyze these problems, then we notice that many disruptions they are putting a lot of challenges before the supply chain. And then there are the complex global network also, like sometimes some canal systems, Suez Canal or others, they are being blocked, and sometimes there are some pirates, they are creating problems. So similarly, there are some other details like some technology has come up, but they are not upgrading this self because of many of the carbon emission things are also coming into picture. So some of the common challenges is that we listed, and then accordingly some of the complexity that we and very variability that is coming into the logistics system is the very interwoven network of the entities like supplier, buyer, manufacturer, retailer, warehouses, and then uncertain market conditions where many of the prices are changing in a very volatile manner, and of course variation in demand and supply is one of the critical things that happens. And in the recent past, mostly earlier we were solving these problems through the OR route like mixed integer linear programs for optimization or dynamic programming for the time variant analysis, or using stochastic models where the variable is probabilistic and time dependent, and many times simulation models also we are using to address some of the problems. Recently, because of the advent in AI, one of the tools which are basically born out of the natural language processing, and thereafter all the generative AI tools has been embedded into it, and also the advent in the transformers through BART and other things are also included into this module. So you have recently heard that Chat GPT, GPT version 3, 3.5, and earlier also 2.5. So all these things where there is a inbuilt learning mechanism. So they are also processing the optimization to problems, provided we should write them in a language which can be trained properly by many other examples too. So when we saw the power of this, then we address one or two problems and also mentored by Professor David Simchilevi of MIT. Then we noticed that several things can be done by this particular advancement in the AI. So particularly its advanced version and having a capability to understanding the generating human language, and it processes large amount of textual data, as you can clearly see. And structurally, if you see, then we have the data in the form of text, images, speech, and many other forms. And then training is to be done through this kind of model, foundation model we call it. And then adaptation to be done with respect to many of the question answer, sentiment analysis, object recognition, and some of the instructions that we want to be followed. And if you go to history, that how these large language models have been developed, then this started somewhere in the 66 with Elijah, then before that, some other names were there. And basically, natural probabilistic language models was coined in 2000. And coming to that, GPT were reported in the 2019. And by, like 2020, GPT-3 came into picture, and generative, like uh, uh, many training kind of models which are there here. So clearly they were looking into account a large amount of data that is coming out of the different sources, and through that learning used to take place. And then Google Bard and LLM, Web GPT, GPT 3.5, all these things are reported up to it now. And now we have the last version that is reported in 2012, May 23, is Palm M2. And many other developments are taking place, and many of databases are also there from where it may be growing actually. So year-wise also, that what are the different kind of model sizes, particularly in billions are the parameters that has been addressed. Here we are showing in a graphical way. As you can see that when we have the last reported, it was coming out to be 530, this billion type of parameters which are being handled by the different LLM models actually. And role of LLMs in supply chain basically is used for, we have data analysis like analysis of massive volume and textual data, and then we have the different kind of patterns which are being formed by the either statistical routes or through AI routes. And these patterns, they need to be what you call giving some useful informations, and then opportunities that we can find out how the process improvements can be done. And because of the next module is optimization, so you can see that how the capability of optimizing supply chain process is to be linked with the cost reduction, profit maximization, or number of resources to be minimized, or number of network size is to be reduced. So identifying different kind of bottlenecks and then suggesting improvements, and of course predicting the demands and inventory levels. Then decision making needs to be done. That is how to assist in the decision making. That is the data driven scenario. Then many of the scenario analysis we have to do that up to 30% variation, 50% variation, 80% variations, like this kind of scenario we have to create, and of course leading to the some optimized solutions. Then need of LLM for supply chain actually arises because of the problems which were global supply chain facing. Means when the item is going from one country to another country, the size of network further increases. So here we found that becoming managing the supply chain became more difficult, particularly when the multiple countries, multiple regulations, rules, languages, and different kind of color, taste, choices varies. So in this case, such a large amount of variations cannot be captured fully by many of the mathematical models. So the data-driven text visuals, they may prove to be more realistic scenario in handling than simply assuming that X and Y and Z are 100 such variables. So LLM solutions can assist in the language translation. Many of the cross-cultural communication can be captured by the LLM models. And this way it facilitates better understanding of the similar diverse context, which are observed in the transactions of at different levels in the global supply chain actually. And the multi-tier supplier networks which are there in the global supply chain, that you can show that it involves many of the suppliers, manufacturers, then retailers, then many of the warehouses, and you can see that among them the difficult to track and manage the items, particularly from which source it is coming up, visibility into the lower tier suppliers. So this need to be found out by the proper identification mechanism and data capturing at different places. So LLMs can analyze several such data, provided insights into the entire supply network. They can also help the dependencies that arises that many tires and many of the labels to what you call capture the problems of intercommunication, sharing of the data, and also helping in negotiating the different level of the prices, stock values, etc. So demand variability and customization is another challenge where we can see that, like say, if you see the some of the train tickets now because of the implementation of Tatkal scheme and many others, where the fare of the particular seat will be higher when you take very closer to the date of journey. So in that case, this problem was taken up by dynamic pricing approach that was followed in the airlines as well as in the bullet trains in Japan. So it is found that because of the customer fluctuating demand, the price of the seat and price of the commodity keep on increasing and decreasing depends on the requirements. And accordingly, it is better to predict in advance that what will happen tomorrow 11 o'clock or what 12 o'clock based on the data available actually. So here LLM can easily analyze the time customer feedback, social media trends, market data to understand the demand variability. This all happens because several information we are getting from the people's social media, WhatsApp messages, as well as some of the like cameras which are capturing the images. So then their coordination among them through agent-based systems can easily be done, and then some sort of you can say variability can be checked. And then many of the technological integration, like say somebody's camera of this brand, somebody's Android system is using somebody other form of platform is using, somebody is using the one desktop computer, somebody using laptop. So many of the technological disparities are there. So they need to be clubbed together or they need to be integrated actually to proper exchange of the information. So found out that many of the advantage of LLMs leading to the quality check analysis, customer feedback analysis, and also in the maintenance affairs, along with the forecasting in the supply chain, inventory optimization, order forecasting, supplier evaluation, and the interfaces that we observe. And some of the, like LLMs attempt to revolutionize many of supply chain management processes are like this. So in process automations, it can bridge the gap between the automation and human comprehension, like repetitive tasks, and then generating many kind of reports and creating purchase orders, tracking of the shipments, payment details, and then some of the institutional memory, like when it happens, what was the case at that time, what was the situation at that time, how many containers were there in the port, all those information, historical things can be easily processed. And in collaborative approach also, like how to share the data, information, videos, etc. This becomes easy when you have the LLMs into the picture. And when you see this, how the lang chain, one of the terms that is used for LLMs in the supply chain analytics, is that data product one, say product two, data product three, and there is structured query language for analyzing them, and then the different LLMs which are there to interpret the output coming out of all these things, and then they must be able to give the answer that okay, after doing this, next step is to do this step like this. So such kind of answers are coming up by this framework. And scenario distribution process, say for example, vessel retainers can easily be planned like this, say from factories and manufacturing, central warehouses, and you can see that many of the distribution planners, they get the order and then accordingly they 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 place their order to central warehouses, and from there actually it goes to them. And many of the analytics that are being used here is like, say, when we follow the structured query language, then the LLMs and at different levels and their databases, how they are connected and how they are processing, and some of the ways that has been described here actually. So how the number of shipments were delayed, this kind of information, how many shipments were delayed the first 7 days, and like such kind of query, if you give it, then based on the data that are there in the systems that have been fed, so it may be able to, okay, say 6, 8, 1, 7 shipments have been delayed like this. And if you see the chatbot, which is one of the automated way of many of the work that we do in purchasing, that we do in the order processing, that we do in the stores. So they are actually, you can say, some of the process automation tools which has been implemented after the advent of generative AI. So they are actually doing like, say, LLM development process, that is foundation of the LLM, and then many of the LLM operations which we do, like fine tuning it and then orchestrating it, and then you can say guardrails and monitoring of the things, and then leading to the chat applications. So this way, how the different information, knowledge, and things are connected, like knowledge messages, then information messages, and then converting them into the embeddings, and then they may get into vector forms, and which goes to the orchestrator, and other custom training data sets and experimental prompt tracker. Then are also being given to data engineering, and finally is go to the fine tuning of the LLM. So like this, how internally things are taking place, there are some glimpses has been shown here through some of the frameworks actually. And already, as we know very well, that many of the LLMs, they use chatbot implementation in the retail stores actually. One of the well demonstrated application of the large language models. So here actually this ARIMA kind of models were used earlier for knowing that what are the stock that is need to be available, and how much we can forecast for tomorrow using the statistical tools. And then neural network came into picture for doing that job, and then less error reporting by using the recurrent neural network for such kind of predictions of the available stock in the retail store or demand forecasting. But recently we found that chat GPT and GPT-3 or LLM models can generate forecast by analyzing the natural language data. And of course, customer feedback also it takes into account. And then it combines the CNNs as well as LLM results in more contextual and accurate predictions where the outcome. So you can say error in prediction becomes very less because it takes into account naturally the feedback as well as the surrounding conditions actually. So some of the advantages that has been listed in retail store kind of things are more customer interaction, more personalization, real-time assistance, and of course, systems learning capability by training and retraining becomes more effective actually. And decision making in the supply chain using LLMs, if we see, then a network has been defined, particularly among the locations, among the distributors, and also storage. So they are part of the entities, and among them, the many of the decisions need to be taken that okay, number of store to be increased or number of warehouses to be decreased, and also where to open new stores in order to capture more market or have the new variety of the products. So a simple supply chain may consist of many of the services and suppliers and customers, they ask questions like this: how many factories should we open? Then LLM models will give you some answer. You can ask, what suppliers should we use? So there are a list of suppliers based on supplier selection algorithms that will follow and give you the answer. Then how much inventory should be kept in stock? So only question you have to ask, and then LM model will be able to answer you, because inside tracking I have shown you that how different algorithms are packed and they are answering this thing actually. And then question is that whether it is able to explain you the things why it is happening or not. So explainable AI is supporting this kind of causes. Like say for concreteness, some of the examples of questions that you ask: what is the cost breakdown for each order fulfillment? Means how much it is going for the setup, how much is going for ordering, how much it is going for the tracking, how much in transportation. Then how much excess inventory have had per month in the past. Then question comes, what happened if the demand is at particular location increased by 10%? So idea is this kind of additional questions that also can now be answered because of the well-trained LLMs actually. Then, so just I take 1 minute break and then come back again. Professor Acharya? Hello? Professor Acharya?
Yes, yes.
Sir, I just take 1 minute break and come back again, sir.
Please, please,
Okay.
please.
So what shall we chit chat about?
Hello.
Yeah, what shall we chit chat about?
You wanted to know about Shiksha Anusandhan? Definitely we'll talk about it. Maybe something tomorrow, something more positive.
Okay.
Okay. Hmm. Professor Kalmulkar, are you here? Or you are mute?
Yes, I'm very much there.
Ah, very good. So in the beginning, I didn't see you, but anyway.
It took me some time for the link for me to connect.
No, it's okay.
I was
okay.
there. I have been there
Okay.
when you were introducing the speaker.
Okay. So actually, now nobody else is there. I will request you to propose a sort of vote of thanks and maybe some sort of summary of what we did. And we had a very nice meeting with Harshad Mehta today.
Okay.
Okay. Things are moving in the positive direction. Let us actually hope for the best. And with
Right.
your all support and maybe support of Dr. Kane, your friend, we'll look it forward.
Who, Doctor? Who you said, Doctor?
Kane. That our friend, actually your friend, is Kane, na?
Spelling?
Kane.
No,
Your
from where?
Maharashtrian
Which
friend.
place?
No, your Maharashtrian friend actually on this design side with whom we interacted. I forgot
Oh,
his
that
name
Tarak.
and you found out.
That design? No, not design. He is in the packaging and all that.
Packaging and all that.
Yes.
So we had a very useful meeting today with our president.
Hmm.
And tomorrow again we are meeting. Let us
Okay.
make it happen. Professor Tiwari being a very busy person and director, naturally he has got so many other commitments, but still he has agreed to give actually this distinguished lecture. He is definitely an authority on the line.
Yes.
So, sir, I'm back, sir. And just want to.
Yes, please.
Yes, sir. So, the APTI guide, sir, which is one of the framework actually that is being proposed and being used also, like how to link the in context learning. Means when we have many kind of solvers, as you have seen, sir, in optimization, Simplex is there, any logistics is there for simulation, and many other packages are there where we are using the traditional tools. But here, when we put the answers and we get something, then this all need to be coded in the form where the large language models can understand. So you can see that many of the solvers, their databases, and then we have a helper to convert them into the proper understanding of the models that each coder can take place. And from user also many of the information is coming up. So you can see users information, then we have in context learning by LLM, and then it again whatever it goes code here for the safeguard it goes, and then from here the input is given to this kind of packages that we are having for further processing of the optimization simulation models. And from here whatever output comes, that again we fed it to this system, which is basically comprising of the coder, safeguard, and interpreter. Actually they are all the different agents which share the information with each other. And then finally, in this way, we can get the results as well as the answer and feedback, and keep on repeating this cycle for different problems and learning. The more and more information, more and more data sets we provide, and it is observed that the accuracy will be more for predictions in such kind of what you call modeling, different data sets learning, and then keeping the result, which may ask questions and then answer will be more accurate actually, sir. Otherwise, answers will not be accurate whenever large scale training is not there, sir, actually. So one simple example which we are taking in Professor Acharya, and we used to solve such kind of problems through the mixed integer linear programs. So suppose a very simple example we are taking, and suppose, sir, we have two kind of roasters of the coffee, and there we have say light and dark roasters, and the company sources coffee beans from three different suppliers, S1, S2, and S3, sir. And as you can see that the two roasting facilities, then they ship them to one of the three items, like each kind of coffee to the three retailer actually, where it goes for selling. The goal is to fulfill the demand of each retailer, which is given here. Say, for example, demand of the per cup actually is given. So, question is this: total cost consists of cost of purchasing the coffee from supplier, roasting it in each facility, and shipping cost of end product to the retail locations. So, the type of roasters we are using is light and dark. Correct, light and dark you can see, and we are mentioning suppliers S1, S2, and S3, and then the as you can see, there are two types of coffee, and then roastery is there, R1 and R2. Then C1 and C2, C3 are the different kind of cafes which are there for serving the coffees. And cost in rupees is given in the brackets, as you can see, shipping cost per gram. So from S1 to R1, if you come, then it is comes 50 rupees, sir, like this. So all other details of the demand and other things of light and dark means which one you require, varieties, two varieties are there. So at how much it goes, that has been seen. So now question is this: in what way we should ship it from which supplier to which roaster to which particular retailer, so that total cost of per cup coffee is minimized actually. So suppose this problem which we earlier used to solve by the mixed integer linear program, if you want to address it by the large language models, then as you can see that these supplies and there are two types of coffees and their details are we providing here. And if you move ahead further in the line, then as we can denote their notations as we do in normally in optimization, like SR denotes the number of units purchased from supplier S to roaster, And then Y, say RL, and D, this so light and dark roaster sent to retail location. And then each supplier, yes, has capacity of CS and other DL and DD, they demanded the light and dark coffee at the different roasters. And then cost of each purchase supplier is also shown, means like mathematical modeling we do. And then this is the way how whole optimization process is captured. And this is to be put to solver. And then solver used to give the answer like, say, if this is the S1, S2, and S3, their capacity is given to you, and then R1 and R2, and then their cost is mentioned to you, and then how we can find out the answers by this kind of thing. So it clearly shows. So different plans now, when we fed into the LLMs, then we can say it can your mouse on each node for each to see the details like from S1 to R1 how much, S1 to R2 how much, S2 to R2 how much, similarly R1 to C-level how much. So clearly it helps you actually to find out the cost, and we excessively transport beans of roastery 1 to cafe 2. It would amount to somewhere like this much dollar as we say in there because of cost, and how much we can save if the answer is correct by processing. So what in nutshell I want to say that many such problems, if you write in a textual language, then the architect framework that we have shown earlier, this has the optimization simulation modules also, and they will do all this analysis. Then it can answer what could happen if the demand of retail one is increased by 10%. What would happen if demand at all retail location doubled? What are using supplier 3 for roasting facility 1? So this were to do earlier, actually we have to do a lot of mathematical modeling and giving the details. But here, based on trained data, we get this answer by the LLM models in very quick amount of time actually. So that is what I want to say in nutshell about simple example of optimization of the coffee roastery that has been demonstrated here. Then question comes, what are the things which are there to increase the supply chain resilience? Because this particular term became very popular during the COVID. And earlier there were different kind of talks were on that each and every supply chain should be lean and waste reduction should be more, less storage, just in time supply. But all these things were getting a bad, impact because of COVID and lockdown and all other things. So then the need was felt that each and every supply chain should have been resiliency. Resiliency means they should be able to meet some of the disruptions which are quite common. So keeping in mind that particular need, there is a term has been coined, what is the resiliency of supply chain? Then Professor David in the around 2021, he gave that model by giving two terms actually. One is called time to, like recovery and time to supply. So TTS and TTR, these two terms is applied, and accordingly he defined that how during the disruptions the resiliency can be checked by proper combination of time to recovery and time to supply. So that is why resilience became one of the key parameters and key performance measures of a supply chain. So with this background, I'm telling you that how this has been come into the picture. And once around 2021, we organized a big workshop of 2 hours of durations where he clearly explained the stress model that how this particular things for resiliency can improve the supply even during the tough situations actually. So now any chain cannot be just say good enough if its cost is less, but any chain can be good enough only when it meets the exigency, it is able to meet the demand at crucial time also, and because of that it requires resiliency. So this help you actually to manage the vulnerabilities which are quite common in the international and global scenarios actually. So adapting to and enduring and ensuring uninterrupted delivery without going through, though in presence of disruptions, is the key characteristics of supply chain resiliency. And how the large language models means generate human-like text and natural language understanding can help you in capturing and measuring that how good resilient or bad resilient your supply chain is actually. So this is another example we have taken, like say Stage one is there, safety stock, demand of the item, at given time, then production output, and how much supply we can maintain. And then the framework says that resiliency formula is there to capture all these things. Then, okay, in this demand, like say stock position, stock out, and then what are the different equations are there. For that is a well-established model when I'm talking about between these two. And then for that, some code are being written actually to capture the either simulation model or optimization models. And then we fed all this thing to the LLM models, which where there is a working code for that. And then resiliency-based conversion model is there, which converts this into the what answer you want with respect to the amount of resiliency it has. And also the same formula and method for contextual training, and then large language models and fine tuning of the same to be done actually, stage two. So keeping that in mind, let us say performance measure in terms of the item available, and then there are the different time zone, like say disruption starts from here, and then supply starts from here, and the recovery starts from here. So this time is called time to recover, and this is called time to supply. So recovery phase up to goes to this much additional level. So the resiliency formula has been given is the time to supply divided by time to recovery. So this way the resiliency matrix has been captured, and then time to survive, which is there X A or X B. If you come here like X A or X B, that shows that the time to survive. And then OA, if you can see from here, like say this OA, conclude the disruption phase and suggesting lower resiliency compared to the OD. So that way, the TTS that we can define the safety stock divided by the demand. So this way we can find out the time to survive. And similarly, time to survival time can also be measured by initial safety stock minus final safety stock divided by the demand. So that is depletion of the safety stock, the depletion of the safety stock as recovery phases. So these are well-established terminology of the supply chain, and you can see at these places also. So this is survival time calculation. Then recovery time calculation comes into picture. That is when it will be recovered from the shock. So this, as you can see, this light blue line shows the demand, and then dotted line, as you can see, this is shows the demand uncertainty. Then from here you can see that like say B, E and B, D and curve CD, this shows that how different ways companies can recover actually. So now question is that we want to capture this thing through some equations. So we have to define like say P, which shows that production in time T and total production output V. Similarly, with respect to time, what is the remaining stock? So keeping that in mind, and duration of the supply delivery. So this we want to maximize, that is the total production output with respect to the duration of the supply delivery. So other constraints which are there in doing this process that has been defined here. So that way we can find out the recovery time TTR. And so idea is this, based on these two only, we have to calculate the resiliency, as I mentioned earlier, that this is the given by TTS and TTR. So that way we will be able to find out. And now when we fed all this data and details, then our LLM will be able to see that, okay, in context, what are the distilled base, some say, for example, squad and fine tuning, what problem of the context training, then updated models, then their integration of the different parameters and codes, and then it will be give you the finally answerable resiliency. So we use this kind of example to find out the TTS and TTR, and then finally give you an idea about the thing. And then many questions like scenario based answer we can see. If scenario one says that survival time is 1.25 days, recovery time in 3 days, then the resiliency is 0.5 rated, demand is made. So like this kind of answer your LLM can easily give once you train the network on such kind of parameters. So that way, very comprehensive way that I have described the combination of different softwares as well as the data sets which can be fed into the architecture of the LLM, and we are able to fed the language like questions, and then we get the responses. And that is what also we see in the chat GPT. So therefore, extended version of that are you can say they are coming into the LLM models actually. And here I can tell you that some of the more difficult things which are included as a internal processing of the LLMs, they are basically the smart prediction and optimization. So when I say smart prediction and optimization, this is basically combination of both machine learning as well as the optimization. And in machine learning, we predict the value of variables at different time, different situations, using all this CNN, LMS, that other models like RNN neural network or XGBoost, AdaBoost, etc. These ensembled kind of learning, and then we use the like say column generation or multi-objective algorithms or others to optimize those things and then find out a very good term called decision error. So idea is this: if you do it simultaneously, then decision error will be less, but if you do sequentially, then decision error will be more. So with the help of machine learning models, these two has been combined, and you can see that many of the strategic decisions where the prediction and optimization has been combined, they are leading to the more efficient solutions. And supply chain network design became more practical, and many of the demand forecasting, which were static, even dynamic conditions also became possible. And many of the risk mitigation and resiliency kind of questions can also be answered when we have the provision of both simultaneously, that is prediction and optimization actually. So what are the different approaches for doing that actually? So as I told you, there is a concept of loss function, which is defined using optimization function with all the constraints. And then loss function need to be either true cost induced by prediction error minus true cost induced by the actual vector. So based on these two differences, loss function is to be minimized. And then if you include the framework like say how the new input feature to predict the target variable are from here, and then as you can see, the historical data is there, and then from here it comes to the prediction model, which is to be done by the machine learning and trained to reduce the loss function defined by the optimization model with all the constraints actually. And then whatever predicted output we get here, this again goes to the optimization model, and then you can say optimal solution corresponding to a particular time zone T, and based on the say demand D, we can find it out, and then difference between the objective function based on those two is actual loss. So this particular thing, a decision loss, that we our main objective is to minimize when we want to link these two different tools jointly for solving the practical problems. So the framework which has been practiced, like say demand factor sensitivity analysis, as you can see, this comes by regression tree model, and these are the different data: demand, distribution, logistics, service quality, purchasing power. This you have to provide to know this. And then once a demand predictor is known, then we have to update it, these demand distributions, and using the like primary facility locations, then many of the expectation and maximization algorithms, and keeping in mind the secondary facility locations and hierarchical customer aggregations, then we process it here through the optimization module, and then we get the data like say what is the updated demand distributions, and then based on the earning cost and packaging cost, finally we say what is the profit of going to earn by both the combinations actually. So like this smart prediction optimization for the many of the e-commerce logistics has been done, and compared to the smart prediction optimization approach, the classical approach for facility location optimization problem we have compared, and decision error is considerably reduced by when we join both actually. So challenges which are there, like say robust decision making we have to follow, and then better resource allocation, then decision support model will be more robust, and of course it should have the ability of the risk management actually. And when we link both LLM and smart prediction optimizations, as you can see, then more and more better result with less error is reported by the LLM that also been analyzed actually. So the transformer model, which are being well tagged with respect to processing all these things. So it is the part of actually when we say that uh, generative AI. So generative AI means where there is a transformer that converts all these instructions which are there, that comes in the form of you can say like demand and all other details, and we have the multi-head attentions here. As you can see, same structure of, and then you put, and here you can see a different level it goes, and then it is processed, and finally there is encoder and decoder kind of concept here, and that process the whole thing. And many times what comes next is come through the probability, dynamic probability table actually. So that predicts that okay, next sentence will be what, or next word will be what, or next number will be what. So these are the details actually of the inside details of transformer which normally work for such kind of scenario. And many of the questions like when you put say she poured water from the pitcher of the cup until it was full, what does it word it refers in this sentence? So suppose if you put in chat GPT, then this gives that she poured the water from the pitcher to cup until it was full. The word it refers to cup actually. Then the sentence described action pouring water pitcher into this cup. How this word it refers to cup actually, this was answered through that particular table which I just mentioned earlier. So like this, there are several other questions also that come into picture, and many of the other informations like embedding through the many contextual relationship in the form of vectors, and the relationship can be captured through many geometric illustrations, and the coordinates are components, that is features that you should describe the each word. So combination of all these things, they also need to be processed to find out what the next sentence that come up actually. So encoder and decoder concept which is used in transformer for finding out the next word, like say how are you, so word 1, word 2, word 3, and how do this decoding. Then based on these probabilities that we have described, so they comes for construction of the sequences actually. So I'm explaining you that how internally it works actually. So many of the newer concepts are there, like there is a term like auto sapiens, where they are basically defines like rapid advancement in the AI, and what are the future shaped of the AI demands coalition of the different technology, policy making, corporate leaders, activists, and consumers. They all actually alignment with the human values. So idea is that this new concept which is being talked in the one of the recent papers in the Harvard Business Review, they are giving this idea that auto sapiens, that is how the AI shifting of the power dynamics, and we have to try to make more social and economic considerations, and some sort of behavior like humans, how it can be brought into this. Then this age of the autosapiens means autonomous entities, where ability to act, decide, learn, adopt, and operate independently, having wisdom, and that enables complex judgment, surpassing human capabilities. So these are all being tagged in the advanced version, which just I want to conclude here that these are the things which may come in days to come by the different kind of other AI tools. And that's I want to conclude, sir, for any question and answer session, sir. Acharya? Hello, sir. I think you just unmute, sir. Yourself unmute. Acharya, unmute.
Yes, am I
Acharya,
now
unmute,
audible?
sir. Now you are audible, sir. Please. Yes.
Yes, because my computer is not working, so I am actually speaking from the mobile. That is the thing. There was some problem here. So please, actually, I think Professor Tiwari has given an excellent talk on supply chain and applications of AI and other tools, that how they could be really used to solve very complex problems. Earlier, as he has told, we used to use only, say, optimization models, mathematical tools, but it had several limitations. Once actually the problems become large, it becomes extremely difficult to solve. And particularly if you are using a mixed integer programming type of model to do so. It is just not possible. So, but through the use of actually AI and the LLM language models, large language models, the things could be really simplified, and we could do a lot of analysis on this, and what if type of things could be very easily addressed. And depending on the situation, you can use either simulation model or optimization model embedded into the system. So I believe this is going to be very, very important for our things. Now, may I now request to pose certain questions to Professor Tiwari.
Kalmakar ji, you joined with Vivek guest actually, huh? Professor Kalmakar?
हाँ बोलिए क्या? हाँ
आप कोई विवेक करके किसी आईडी से ज्वाइन किए क्या सर ऐसे जो है?
नहीं, मेरा नाम
लग
क्या
रहा
आ रहा है?
विवेक,
Professor
VIVEK.
is there right from the beginning.
Yes, that I can see, sir. I can see him. Yes.
Oh, is it?
And he's
My name is
to you.
appearing as,
Hmm.
I don't know. It is my own laptop.
चलिए सर, कोई बात नहीं है. Anyway. Yes,
So
sir.
I'd like to make an observation and then pose a question to you.
Yes.
The supply networks that you've talked about are looked at from the cyber physical perspective. And the outcome of a cyber physical approach is a lean but fragile supply chain. One of the frontiers is that we are moving from, in Industry 4.0, we are dealing with the cyber physical side. In Industry 5.0, the human is brought into the picture. So you're looking at a cyber physical social system. So if I'm right in terms of you coming up, your supply chain or what you're driving towards through optimization is a lean supply chain. It's going to be fragile because of the human component. So my question to you is, how do you make a supply chain fail safe, taking into account the cyber, physical, and the social dimension?
Actually, Professor, I just want to explain you. I have not described anything called cyber physical system, which is the environment and which is the kind of digital, like arcade within which these things should function. And certainly nowadays data capturing of different types cannot be possible unless we have a very good system, either through the different IoT devices or through mobile cameras or many other things which are coming up. And of course, most of these computations are also done through the cloud. So you can say that these are all some of the support system that has been derived from the cyber physical systems. So you can, that is broadly I can say. But what I described actually, these are all the computational things. Means once we have the data, then it does not require the, suppose what I'm talking that processing of the data you are having, then how you can get the answer. I'm not talking this what is there with the cyber physical system, what are the weaknesses of that. I am just talking about if you have the data of different types, which was earlier not able to be processed because of the there were no such methodology was available. But because of the large language models which are deriving its trait from the NLP, as well as having different modules of optimization, simulations, etc., they can give you the answer. I'm not talking lean or thick or you can say fragile. I'm simply asking you that what computational support now being available, through which all those answers which were earlier very difficult to get, now in the conversational forms you can get those answers. Correct. It has nothing to do with the fragile or lean systems. It is only able to give you the answers if you provide the data in the form which you are watching by different sources. Okay, sir.
Well, let me do a follow-up question on that.
Tell me.
You've talked about optimization, NLP, mixed programming, things along those lines. all these, the solution to those are anchored in the Karush-Kuntaka conditions, which means that the model is perfect. So that's why you can justify having a single point solution on a convex surface on the periphery of the convex surface. And the other thing is, in the Karush-Kuntaka conditions, the objective has to be perfect, not approximate, not aggregated. It's perfect. Only then can you justify going to a single point solution. So now in the context of this statement, does it mean that you are really truly getting, you can optimize a supply network? Because there's a huge amount of uncertainty.
So what I feel Professor Farooq, your answer, actually there are many stages. When you say the convex optimization problems and solutions, so these were the cases now when say nonlinear programming and NLP2 are different things, I tell you. When I say here natural language processing, that is when you have data in the form of words, sentences, videos, etc. I am not talking NLP, non-linear programming, where Kuntaka theorems or Lagrangian relaxation models were used to convert a non-linearity into linearity. That I am not referring here, because we believe that the simplex package which we are having and the way in which we formulate the problem, anyway you formulate it, that you describe in the form of a certain language, sir. And that particular thing will be taken care by the different transformers which are there in the system. Correct? So now question is that whatever transformer you are having, say simplex model is there or groovy model is there, they are being nicely used. And within that, sir, all this your contextual thing like whether single point solution, multi-point solution, Pareto solutions, they have been already packed into that. Suppose if you want to a multi-objective problem you solve, there is one objective maximization, other objective minimization, then certainly you have to go to Pareto optimal, and then you have to find out crowding distance, you have to find out solutions within that framework. So all such things has been there in some way or another way into that module of the optimization modules, correct? Here I am not talking about that whether they are processing through the convex route or through the Kuntaka theorem, they have used KTK conditions, they have seen. These are all the things which has already been resolved and already put into some sort of the package which has been inbuilt into the system. I am talking that in what way many of the data that you cannot process through that one, if you add, then how can you get a solutions through different transformer systems which are they are part of the large language models, correct? So they are part of that individual modules, sir. Correct? It's a computational system I am talking. Here individual things are well taken care. Like say, suppose I ask you, is there anything where simplex can solve when there is a large scale nonlinearity, like say x power 5 plus y power 10? So question is that those kind of answer you go on doing a lot of iterations and find out different conditions, then do. Best way is that for such kind of many complex and high dimensional problems, you go and use illusory computing. Solve those things by that GA route or AI route or random search route, you can solve it. So for that, there is one way set of solution, then there you can never guarantee any optimality. Only near optimal solution will come out of that system actually, sir. So question is that all such things have embedded into that optimal modules which are there. Here we are talking, sir, if you have the both, say prediction and optimization, how will you find out the decision error? And you define them in the format which the system wants, then you can get even many iterative answers also, which were earlier difficult to get because every time you put the data and get the result, then interpret it, then draw the graph. But now here, because of learning and continuous learning by the systems, you can able to get this thing in a very less amount of time, sir. That is what I want to say. Okay.
Thank you.
Yes.
Sir, I have a question.
Yes, sir.
One of the very interesting things that you showed was that example of applying tokenized model on coffee beans, etc., and deriving.
Yes, sir. Yes, sir. Yes, sir.
Now, in a realistic sense, a lot of companies are hesitating to put such proprietary data into the public LLMs because of fear that my so-called trade secrets will go out and so on and so forth. In India, there are many efforts I am aware of on the computer science side to create Indian language LLMs, etc., as sort of private enclaves, which will not necessarily be run on Microsoft infrastructure or Google infrastructure or many of the well-known LLMs. They might use open source or some Indian infrastructure. As part of one of the slides that you had right in the beginning of the national infrastructure for supply chain, Gati Shakti, etc., is there any plan to create such enclaves for private data? For example, disruption management, for example, customer preferences, for example, etc., which are very Indian specific, like almost like a Wikipedia Commons kind of a thing, where Indian companies can put their data out there. There is no fear that it will leak out to external entity, etc. Are you aware of such private enclave things, or people are generally okay to put things into the public global LLMs?
No, sir, what you said, you are very right. Actually, when we were talking to some of the companies, particularly we are also having some sort of relationship with many logistic firms, sir. Including the pharmaceutical companies, also including the e-commerce companies. And currently, just I am sitting here, and there is one course is going on also with the Flipkart actually. So we are having many. What you said very right, sir. Currently, government effort is there with respect to all this thing. Is there is a unique software, as you know very well, sir. Correct. That has been designed to facilitate the many of the people who wanted to send their items, and many of the truckers, many of the other port operations are also they are going to be there to facilitate the people, so that one particular software can help actually to know the many things. And it is not fully used, but hopefully the what DPIT and others believe that in days to come it will become more popular, sir. Correct. So this is one common software through which actually, like not software, you can say platform, which government has created called ULIP, actually Unified Logistics something platform like this. So that is one thing already came into picture, sir. Now question is, as you said, that individual companies, so certainly like ChatGPT is there now, so they are using their language models for their own company they are defining. And they are using their own GPUs also, sir, for calculation. They are not relying on the cloud actually. So for a small scale work, it can work, sir. But I think for where they have to collaborate with some partners actually to do this processing work. Because many of the larger network data, if you put, sir, certainly you require the broader capacity. And in that case, actually better learning means more and more data. If you learn, then better result will come up, sir. So I think for that purpose, they have to find out some data breach agreement between the two parties which are providing the platform and which are using that platform, so that because without that, these different agencies, what you call agent system interactions, that becomes infeasible. So certainly either they have to create their own processing system, or they have to have partnership with some of the existing firms to share these things. That is what my answer is there, sir.
Thank you.
Sorry, sir, I have no questions to ask because it was totally out of my depth, I should say.
Yes.
But if I don't mind, I think I will try to take you away from whatever you have talked. I had asked this to earlier also, but anyway, I will ask you this. In India, this is totally away from your thing. Please understand that. In India now, because you are talking about languages, in India now, we have several what is called official languages. Some fellow is saying in Hindi, some fellow is saying Tamil, some fellow is saying Malayalam, like that. And essentially, it becomes that when you go from state to state, they are not able to communicate. Okay, so I think it already these things are there. Instant translators, online translators. Online means instant. As you speak, it translates. Such a thing probably in Parliament they are using, or in US Senate they are using. Are we not having that? And in other words, can we not have a unified language all over India? Everybody has this. Then this problem will be solved. I know that, for example, Canada lives very well with two languages. One fellow talks French, the other fellow talks English. They live with it. But can we not do that in India? Thank you.
Sir, actually here the language does not mean that the what here actually very different way. The idea is that, sir, it's a way of expression. Say for example, any problem. Now suppose you solve this in manufacturing context, then dictionary will be of manufacturing. If you talk in terms of the logistics, then dictionary of stock, say supplier, retailer. So they are the dictionary of the words, sir, na, which are being used to synthesize the sentences for business answers actually, sir. So mostly what they are trained actually, they are trained. Suppose you have designed all the network transformers in the English like sentences and the model is also like this. So only this answer will come up. But those who have, say for example, coming from the China and others, I don't know how they are using it, but at least what is being developed till now, it is like that for every domain we have to build up the dictionaries actually, sir, so that it can convert into, like say ontology is there. So many of the ontologies are coming up. They are created actually to link the sentences for knowledge definition. Suppose any knowledge is there, that knowledge is to describe through ontologies, so that its processing, its data mining, text mining become easy. So if whether Hindi, Udiya or Telugu, any language is there, sir. So suppose once they have this kind of analysis and then conversion. So suppose you want to express a supply language or you want to express a retailer's problem in India, then corresponding in English can be there. So if you fed into English, then model will automatically take place because there is no problem at all. But only thing is that it cannot be something like this. Many things it can understand. Here language means definition through which it understand the instructions. That's also correct.
Okay, sir. Thank you. Thank you.
Acharya sir, again you just check whether your voice. Huh? I think, sir, you are not audible, sir, properly.
ଆପଣ ମ୍ୟୁଟ୍ ଅଛନ୍ତି ହଁ ଆପଣ ମ୍ୟୁଟ୍ ଅଛନ୍ତି ବା
Manoj Kumar ji, I think
Ah,
now
sir.
Vivek is speaking.
Yes, yes, sir. Yeah.
Yes, I have unmuted myself.
Now, sir, I can listen you. Now I can listen you, sir. Yes. Yeah.
No, it's okay. So, Professor Tiwari,
Yes, sir.
definitely what actually you have told about that, how can you use large language model to convert actually some of the problems related to supply chain into a form where the solution could really be found out using, let us say, this optimization tools or simulation, and that is definitely helps. And it is actually welcome thing in that direction. But this problem still remains. The real life supply chains are actually much more complex, involve actually several stages, several alternatives, and particularly in the global context, if you think of, so many things are really involved. Whether such a problems could really be solved through this type of approach, I have my own doubt. Would you like to really comment on this? Because
Yes.
that will be, you think of actually in the typical even manufacturing context, if you think the supply chain will consist of thousands of suppliers, maybe few hundred stages of manufacturing, distribution channel is like that, and also the various modes of transportation. So can we really do so? In earlier mathematical models, even if your data is available, they have failed to do this thing.
So actually, sir, just to answer you, sir, actually the difference in current era and previous era was that earlier models were there, and in the model data used to be put. Now data is there, then accordingly models need to be created, actually, sir. Correct. So question is, today's era is called data-driven modeling, sir. In the data-driven modeling, what happens? The questions need to be getting sometimes redefined also, because they are the different nodes, sir, in the neural network or recurrent many layers are coming up. So interaction level is sometimes not defined also, but keep on defining by different examples. They are training and learning, sir. So my idea is that, sir, in days to come, the error which comes between the final, suppose, how do you get the answer as you say? So there are two things, sir. One is called training data and testing data, sir. So based on what data you are having, you train the network and then you test and found that what is the error level actually, sir. So question is that when you found that error level is less and less, then anything that you put, whatever maybe vast or large network may be, sir, because it is working on your data only, sir. Correct? What you have defined earlier. If you have defined all the wrong data, then you will get wrong answer. But if you have defined the things which are happening in your company or in your mahal, in your environment, then accordingly you will get the answer also. Like say I tell you, a company has given us a data of cement, demand. And many times what they were doing, sir, between 3-4 cities, they were giving dot. Sometimes they were defining weak demand, dot. And sometimes they were not showing the thing actually, what devices they were being used. So when I asked them what value we should put here, at least something you tell, they say that actually that time it was not recorded, not done. Okay. Then we have applied some other quartile method also to clean the data. Then when we applied that method also, then what answer was getting, they say that, okay, again, this is more than what we are actually using. Then again, we refine their data only we are refining. And when it comes to more and more refining, cleaning, then they, okay, now it is more close to have achieved in previous times. So accordingly, then we predicted that they were getting the more closer result than what it was expected. So idea is this, sir, we have defined the data, we have put the data, and now model is to be picked up by the system itself, sir. Correct? Earlier was there was model and you put the data. Now data is there, now automatically develop the model, develop the relationship among them, and then you get the output, sir. Correct? And inside that, whatever algorithm methods you pour, they also keep on trained based on this data only, sir. Okay, sir. And many unknown relationship also getting defined now, sir, inside that actually, because they are passing through many layers, and that is why called generative AI. Generative AI means many rules are generated which we do not know whether they are correct or not. Correct, sir? And that we have tested with the time only, sir. Correct.
No, I do appreciate this particular thing, advantages and all this thing. My only question was, for smaller problems, all these things actually you can do. But for large problems, even getting so much of refined data and putting it in
That
some
is,
way,
that is,
whether
here
good
we
or
agree.
bad, that still remains a challenge. That is
Here
what
we agree
actually
with you. Here we agree with you. If data is not clean, data is not clear, then you can't expect, sir. Of course, you will get result, but that result may not be good result for you, sir.
Okay.
Yes.
Anything else actually that you would like to say?
Sir, I can say that there are many.
I request you to propose a vote of thanks and say something about yourself and what IIT is doing.
So I will ask Tiwari ji a question before thanking him. Is there some analogy between the procedure that you adopt to get the solutions? You have talked about large language models, linear programming. For example, I remember during my BTech project, I had to come up with the best linear fit to a curve, piecewise linear fit. Best piecewise linear fit to a curve, where number of segments is given, but the length of the segment and slope of the segment is are the two parameters that can be adjusted. So Is there some analogy between a problem of this kind and the problems you have been discussing in the supply chain?
Sir, actually, it's slightly different. So what happened, what you said, it's just one small component of the big thing, actually. Say, for example, fitting a curve based on the data, or there are some piecewise methods that has been given.
Let me, Tiwari ji, let me clarify. It is not fitting a curve based on data. A curve is available. You have to fit a piecewise linear curve to a curve which is available, piecewise linear. Not
I understand,
to a data.
sir. I understand. See,
where the number of segments is decided, but the slope and the length of the segment is variable. Each segment.
If I just capture your problems, and let's say, for example, number of segment you define and initial and final points, points you define, direction you define. Then what happens? This becomes a lot of clustering kind of optimization, actually. Correct, sir? So these are things that we require to do. That can be, there are many models for capturing this, sir. What his problem is that this is one such small module of the large language thing, sir. Like there are many such transformers which are there to convert the information data into one way, another way, then many useful information like this. Say, for example, you say this way, this is the linear piecewise model, and there are 4 segments, which is the final answer. Correct? By your answer. So like this, 4 calculation has been done by one small component. Then suppose there are hundreds of the x1, x2, x3 and y1, y2, y3 are given. You want to find out, okay, in what way the Z will come up, which has minimum error than the today's and tomorrow's data. So that is another way. Like this, there are many ways you can give the input, but there should be one way where the whole thing are getting transformed to say, okay, by that piecewise linear, by their simulation model, by this, what you call making the, you can say mapping kind of model. Final answer is this: if x1 increases by 10%, y1 increases by 20%, then what is the probability that z is increasing by some 2% or 3% like this? Suppose such kind of answer you want to find out real life problems, correct, sir? Then you have to define all these data, situation, models, tools, and then based on training and testing, finally, if you make it perfect, then it will give you the better answer. That is what is being the large language model, sir. Okay, sir?
So why the word language is used here?
Because we are describing the data. Say, for example, you earlier say 3x1 plus 2x2 is less than 8, sir. Suppose you say that 3 into variable x1 or plus PLU, yes, like this also, less than also you can say. So that has capability to translate that also, sir. Idea is this. Means when you can describe in any form, video le aaya, sir, video ko bhi convert karo. Large data, na, sir. Very many ways that you can write down like this. Correct? So it's a more, very wider set of the input defining modules, actually, sir. Correct? That is why you call large language data, sir.
No, large I understand. I'm talking about the word language.
Yeah, you have to write, na, sir. You have to write, like say chat GPT, you write, na. Say in chat GPT, you write, na, ki what will next word is there, like, sir, correct?
Okay, sir. So I think since it is my pleasant task to propose the vote of thanks, you can see that the time of the question answer session was of the same length duration as the talk itself. I feel that is an indicator of the extent of interest the talk has generated. And I know Tiwari ji for a long time, but this is the first time I have heard some talk continuously for about 40 minutes on a topic that is very dear to his heart. So I once again thank Tiwari ji and hope he will visit IIT Bhubaneswar sometime.
Sir, actually, myself and you meet and talk mostly AICT matters, actually, correct? Now we are meeting all the different language, actually, correct?
Right.
Yes, okay, sir. Thank you, sir. And thank you, Professor Acharya and everybody, because I know Professor Farooq ji also and everybody.
Thank you, Professor Tiwari, that you took actually gave such a beautiful lecture. Many things actually very close to my heart. And as you know,
yes, sir,
you and me, we all belong to that supply chain area. Only thing, sir, I am from traditional side and you are from the modern side. That
Sir,
is actually
actually, my first class in supply chain was with you only, sir. You were teaching and I was sitting. Sometimes when you are absent, then only I take the classes.
No,
actually,
no,
sir.
no. It is
Yes, sir. Yeah.
no. It is absolutely okay. It's very nice of you, and you have taken it actually much further. But a lot of things have to be really done, and but anyway, now everybody actually talks about the supply chain. In fact, it has become actually a buzzword. Nobody is now talking of anything else. Only they are talking of supply chain, right from the Prime Minister to the last man. And all credit it's so popular. So thank you very much
Okay, sir.
for giving such an excellent thing. Can we, with your permission, can we really share this thing to with others?
Yes, sir.
They are
No
all
problem.
being recorded.
Yes, sir. No problem. Sir. No problem. Sir. No problem. Sir. No
Hello.
problem. Yes, sir. No problem, sir.
Professor Thierry?
Sir, I have no problem. You
problem.
can share it, sir. You can share it. Sir. No problem. Okay, sir.
Okay, that will be so nice.
Yes.
So thank you so much, and we'll have many more meetings and all these things. And if you are coming anytime this side, Bhubaneswar side, please do drop in. I am here. Professor Karulmukar is there. There
Yes,
are
sir.
many people. Many of your well sir, many of your students are here. So I think
Yes.
the things will be very nice. And also sometimes if you want to, if you are coming to Kharagpur side, please also let me know. I will
Yes.
go and personally meet you.
Next, sir, I will come to Bhubaneswar, sir. No problem, sir. Okay, sir. Thank you, sir. Thank you very much, sir. Okay, sir. So, taking your permission, sir, Professor Acharya, quitting. Okay,
So, Manoj, this is Farooq. I will email you. I don't think we connected today. I
sir,
will email you,
yes.
and
Sure,
I seek your advice because we are working on a real life issue. It deals with dynamic management of supply networks.
Please come, sir.
And
I will invite you to
and
Bombay,
so-
sir. I will invite you
we
to
have-
Mumbai, sir. Apaiye, sir. Please. Okay, sir.
Yeah, so I will send you what we are thinking about, and I'm interested in connecting with you or your faculty member who may be interested in this work so we can collaborate on it.
Okay, sir. Okay,
Okay,
sir.
so
No problem.
I'll send you the basic stuff that we're looking at
Okay,
and help in that.
okay, sir. Yes, thank you, sir.
Thank
Thank you
you.
very much. Thank you, sir. Thank you.